我看到我真的不知道这第二题，我说这还没有。
So, good evening. So it doesn't turn on. And good evening, ladies and gentlemen. I think we can start now, right? So please get ready. Okay, I have uploaded the code to the IVLE folder. There are three code here. So one is for dictionary approach and the other two are for the text classification. I will spend about 15 minutes for dictionary approach and then about 40 minutes for text classification. And so let me first introduce the first method in dictionary approach. So in the first method, I will not use any specific text processing package, and I will just use some basic R function and some fundamental package. But then when it comes to the text classification, I will use the specialized text processing R package, the TM package. Text mining stands for text mining, and also the another R package specialized for the text classification, RTextTools. So let me first introduce you the first method. Typically, when I start the RStudio, I will remove every the variables in the environment, although it's now empty, and remove the environment and clear the console. Okay. Then we start to load the libraries. If you haven't installed them, then you have to install those libraries. And the first library is PLYR. Actually, it contains a bunch of useful functions, like the LAPLY. So later I will use the LAPLY. What does this function do? It's just like a simplified or an R version of for loop. So typically you may have written so many for loop or while loop in your C or other programming. But here in the R, typically we use this lapply or maybe some, depending on the input or the output of the data type, you may use like sapply, mapply. You can just Google and check the detailed manual for each of these functions. So here, I will use the lapply function from this package. And then I will use another package called string R. It is used for some basic string processing. So I will load these two libraries and then read these lines of this txt file. So what's inside the txt file is just some textual, only the textual information that is crawled from a condo review website. So this is for one condo. There are 38 reviews crawled here. So after reading this txt file, the input text has a length 38. So each element corresponds to a document, and you can use the class function to see the class of this variable. It's just character, so this is the vector, and the fundamental element is character. You can inspect the element. You see it's just pure text. So after loading this data, we will start to construct this function. This function is used to compute the sentiment score. It's a quite large block of function, right? So I will just first tell you how we call this function. So of course, dictionary approach, we need the dictionaries, right? So I have also prepared two TXT. One is for the negative words dictionary, and the other is for the positive words. So you can see in the negative words, actually some of the words have different forms, right? So in this sense, we do not need to stamp these words, right? We just use the original form because this dictionary contains various kind of form. Also for the positive word, you can see this like past tense. So after reading these dictionaries and this text txt file, we call the function we defined to compute the score, the sentiment score. So the argument is the first input text and positive dictionary and negative dictionary, and also the dot progress parameter is an option that tell the program whether we need a progress bar or not, and the default is none because we have here. So we start to define this function. It has these four arguments. First is the sentence, right? So the sentence actually is the input txt when we call it. So inside this function, you can see the function's input is a kind of long vector, right? It's the 38 length vector. So what does this function do is to apply the sentiment score computation to each element of this vector. So you can see that here the input text 1 is a sentence, or you can see here we call it a document. Perhaps you have your self-customized document, which is a very long paper or article. Here we just define the document as just a sentence. So this function will apply all the following bunches of code to each element of this input text. Why I say so? Because we have the LAP apply here. As I just mentioned, the LAP apply is just kind of our version of for loop. So it apply the format syntax is that you send a list here. So the list is the sentences. It's a bunch of documents, and then this lapply will apply the function to each element of this vector. So the function is defined here. You can see that actually this has been the embedded level of function, right? This is the function inside the outside sentiment computation function. So inside this function, what it does is to compute the sentiment for each sentence, right? Because the lapply will apply the function to each element. So each element is a sentence instead of sentences. So the sentence, what we do to the sentence, like here, the sentence here, what we do is we do some pre-processing to the text. We first remove some punctuation words. Also, we remove some like control characteristics and the digits. Also, we transform all the letters to the lowercase with this function to lower. You can see this is a little bit complex. That's because depending on your operating system, sometimes the conversion to lower may have some bug. So it may it encounters some error. So there is like some try catch error here, so that your program will not break down. So this is the convert to lowercase part. And also there's a string split part. That is, we split the sentence here to word by word, and then this string split function comes from the string R package I mentioned before. So this is the second package we use here. And then the returned variable is in the form of a list. So we need to use an onList to convert the word list from the list type to a vector type. Why we need to do so? Because for the match function later we will use, it requires vector input argument instead of a list. Otherwise, there will be error. So we split the sentences to words now, And then here the match, what does the match do is to see whether the word appears in the positive or negative dictionary. For instance, I just commented this line, so I just illustrate its usage. Here, like the S is the word you are trying to match, and this is a dictionary containing only 2 words. So if S is in the dictionary, then it comes out the position. If it's not inside, like the B is not in the dictionary, then it comes out an A, not available here. So with the match function, we can get the for this sentence, we can count how many words are in the positive and how many words are in the negative dictionary by using the because the value of, if it's not inside the for example, if a word is not inside the positive dictionary, then it returns an NA, right? Then we use this isNA function to get the value whether it's inside or not. If it's true, then it comes a true. Then the value is 1. So we sum this like pos match and also sum the neg match, so that we can know how many words of this sentence are in the positive dictionary and how many are in the negative one. This score is simply computed by minus the negative from the positive, and then the score is computed as is returned. So the return score is for each sentence, right? But since we have this function is used to apply the whole process to each sentence, then when we call this score sentiment function, actually we can know the score for each sentence, right? So you can just imagine it as a kind of hierarchical structure of function. There may be 3 levels of function being embedded here. So the returned data is in a data frame type, and it includes the original text and also the score. So that's the whole function we use to compute the sentiment. Let's run this function and what's the result? Okay. So after we load this function, we then load the functions here now, and we load the dictionary, also the positive negative dictionary, and then we call this function by with this argument, and the progress bar is set as the text. That is, the output will be a progress bar in the form of ask2 text. So it just finished. Let's look at what was inside the score. So there is the score is here. For each sentence, we can compute a sentiment score. And then actually we can extend this data frame by adding 2 columns. One is the very positive and the other is very negative. So if the score is larger than 2, then the very positive is 1. If it's less than -2, then the negative is 1. Then we try to expand this data frame, and you can see there's additional 2 columns here. So this is the score for each of the sentence. If we are trying to see the aggregated view for this condo, then we need to aggregate all of this result. And we just count how many commands are very positive by using the sum, and how many are very negative, and use a very simple formula to get the percentage of good reviews. So you can see the score is quite high because there's several, like here you can see very positive. There are some review very positive, but almost no review with the very negative sentiment score. Okay, so this is the first dictionary approach. Do you have any questions? Please.
I got one question regarding the progress in the both and different functions. You say it was used to control the progress bar, but how does it work?
Oh, actually, it will use some embedded function of this. Like here, when you see where it is applied, so the function actually it has in this LAPLY, it has embedded the function to show the progress. So this is embedded in the function, but the function would accept additional input. Like here, you have the vector to be processed, and here is the function to be imposed in this function. And also you can add some other arguments allowed by this function. So that is here. You can see the boundary is quite a bit far. Okay. So the dot progress is embedded in that a bit higher level function. It allows you to show the display the progress, because it has already been embedded in that function, so you don't need to take care about that. Yeah. So the LAPLY actually, as I said, it comes from the PLYR. I think perhaps most of you have installed the package when I graded this assignment, right? But perhaps you don't know why you need to load so many packages, or maybe you know. But actually, this package comes with many functions. So perhaps when you are trying to load this library, you can check the menu to see the function list, and maybe you can find many other useful functions. Quite convenient. So now let's come to the text classification. The first method is trying to use like a very native method that you can use your previous assignments code. You can use like you use the R part, use the like E1071 package to run the SVM or naive Bayes. So you can use those kind of machine learning algorithm specialized package to run to do the classification. But before you do those classification, we need to do the text pre-processing and construct a document term matrix. So the high level is that we first do the text cleaning and then construct the term document matrix, and then use the document matrix as an input to do the chaining. We can apply various kind of algorithms to do the chaining. And then this is the high-level idea of this method implementation. And the second version is that we will use a wrapper package. It comes with 9 algorithms. So actually it only allows you to use those 9 algorithms. You have no other choices. And then it's very convenient in that it seems that you do not need to specify in terms with the pre-processing steps. It seems clearer and simpler. But however, when later you will see actually it has some other constraints. So let's first look at the first version. And in this text classification, I will use a very very important R package for data processing. That is the TM package for text, stands for text mining. So you can just read the manual, use this command, vignet tm. Then you can see the you can see all of these instructions. Okay. Or you can just download it from the through Google. So I first load this library. I need to load this library. Also, I will need another package, the Snowball C. So it is used for word stemming, as you just learned, to so that words with different forms will appear the same. First, let me load this data. So the data and this code actually they follow the textbook chapter 4. I have make a bit revision to the original data file because otherwise my device would not recognize some records because of the coding issue, character coding issue. So I just load the revised version of the CSV file. It has also been uploaded to IVLE. First, let me just clean everything we have done before. And then load this data. So you can see the data has just only 2 columns. Actually, if you see the spam, the spam CSV is quite clear. So the type is the labeled type for each SM. So whether the message is a ham or spam, it has been labeled. And the text is also listed. You can see some of the text is quite messy, right? So we need to do some data cleaning to first following some standardized routing. So after we load this data here, is in the form of data frame. So the data frame is also quite often used data type in R. So we can use the structure function to inspect this variable. This comes out a quite concise version of this variable. It has some example of the type value and the text value. And then we can also tap and see the percentage of the ham and spam. This is just have a brief review of this data we're going to process. And then we start the text pre-processing. As I said, we need the text mining package. I load it here. And then the text, most of the R package to process the text would require you to provide a corpus type of variable. So this is the way to construct the corpus type variable from the raw text. So you can see that after this command, I construct a SM corpus. The data type is large V corpus, and also you can use the class to see the class function to see the class of the variable. Usually you may not, sometimes you may get to some unfamiliar package and you are not sure about this class type or variable type, data type. Then you may need to inspect this variable with the class function or the structure function or the type of function. So we print some example here to see its content. So here as character is a function that would abstract only the content here. Otherwise, we cannot directly get the content. So the lapply is also a very commonly used function. But here, do not confuse the lapply with the lapply function I just mentioned. The lapply is a base R function, but in the previous function is from the plyr package. So all of these functions are all quite similar, but they differ. The only difference may be just the data type of the input and the data type of the output. The input may be like data frame or vector list or the array, and the output is also the same. So they are just a kind of different combination of these data types. You need to check the menu to see the argument and output of this function. So this function will apply this as character to the elements of this SMS corpus, and then to return a list. The L stands for the list. And then we can see some example here. Then we can start cleaning, and during the cleaning step, I will show the change back and forth, and so that you can see how the cleaning step proceeds. So we first store the original corpus with a new variable, and then the first step is to transform the letters to the lowercase. So the content transformer is a function embedded in the TM package. It's in this TM map is also a function of the TM. So the TM map, the first argument is the corpus, because we have already transformed the raw text to the corpus, right? And then the second function the second argument is a function. So the TM map will map the function to this corpus. And the function here, you need to know here that we need a content transformer here, because why? Actually, the toLower is also an embedded R function, but we cannot directly use the toLower here, because here the TM is going to map the toLower to a corpus. So the content transformer is used to wrapper this function a little bit, so that this toLower can process the corpus instead of other basic R data type. So we just do the transformer, and you can see the result. Here, the vector the letters are all in the lowercase now. And also we may want to transform some other meaningless characters to the blanks. So here also we use the content transformer, but we self-define a function instead of using the basic R toLower function. This function is defined by ourselves, and we call the gsub. It's also a base R function. So the gsub will gsub means stand for substitute. So it will substitute the pattern to the blanks. So when you call, this is a basic function that has been processed or been wrapped by the content transformer, so that it can be used to process the corpus. And then the TM map will apply this two-space function we defined to the corpus. Because the content transformer in here, the gsub requires an input pattern, so the input is also here. The argument is here to transfer to the gsub. Here there's maybe no difference because there's no such kind of special character. And then we use the remove number and stop words and remove punctuation. These three are all functions, and they are all embedded in the TM package. So we do not need to do the kind of a little bit troublesome work here. So we just simply use the remove number and the stop word punctuation, and you can see perhaps some of the words have been removed. So after processing the U, R, many of the words have been removed. Then you can see there are so many blanks. So we just remove those blanks. Later, that's the next step. First, before that, we need to stem the word. As I said, I will use the snowball seed library, and it has the word stem function. So I just load this library, and actually the TM will call the snowball C function. So you can see actually here there's no like the word stem function. I do not write the word stem here because the stem document has already taken care of that by TM package. But I need to load the library. So you can see this is an example of what the word stem function do is to transform the words to the stem form. And also I apply this stem to the corpus. Then maybe you can see some of the word may have been changed. The checking has been transformed to check, right? So the last step is to replace some blanks to stripe the additional blanks and use this stripe white space. This is also a function comes with the TM package. So we can see the examples. These are several of the examples. This is the several of the example before processing, and this is after the processing. Now that we have cleaned the text corpus, then we use the cleaned corpus to create a document term matrix. Then the document term matrix also comes in the TM package. But it's worth to note it only accepts the corpus data type. So that's why you have to create the corpus at the beginning. So just to run this line of code, then you will see the SM document term matrix has been created here. You can see it's a large document term matrix. You need to differ this document term matrix with the basic R matrix type. It's not a traditional matrix. You can see that in this matrix it has the IJV to store the sparse matrix, because as you can imagine that the term document matrix may be quite sparse, right? So it will be quite inefficient to store the whole matrix. So like here, here is an example. Suppose you have a document 123 and the term 122 to 100. Then suppose in this document term matrix, here it has the term 1 appears in the document 1 3 times. Then in this document term and specialized document term matrix, you will have an IJV value of 113. So if the matrix is full, then there will be 3 by 100 elements, right? Then there will be 300 row here. So the I is the row out, the I is the document ID, and J is the term ID. So you can see in this SM DTM, the I has a lot of 111, right? That's the document ID. Then maybe you want to check how many terms there are and how many documents, and you may want to also check the frequency. So here I use max, and you can use summarize or other descriptive function. So you can see there are like more than 5,000 documents in total and more than 6,000 terms. And the frequency is the largest frequency is 15. So now we have created a document term matrix. This is this is the one of the method to create the document term matrix. There are some other methods, quite simplified version. That is, all we have done just now can be simplified by using these several lines of code. So the document term matrix, actually it allows you to specify a lot of parameters. So you add beside the corpus you pass to the function, you can specify whether you want to convert the uppercase to lowercase, whether you want to remove numbers or remove stop word and remove punctuation, etc. but the result may not be the same compared with the previous step-by-step version, because actually here it's a bit black box with respect how they order this step, because like previously the step 1 is to remove number, step 2 is to remove the stop word, but here you are not sure about the order of this function, how they exactly execute this processing. So the result will be a bit different. But it's also feasible to use this function quite so the code actually looks quite concise, right? It may take several seconds to run this. Okay, finish. Then you can see how many terms. A little bit different number of terms. 5,000 more around. And here is another. You can use additional parameters weighting to define the weight of this. Like here, actually the default weighting of the document term matrix is the term frequency. But sometimes you may use the TF-IDF frequency. Then you need to specify the function here. So the weight, the value of the weight should be a function and defined by you. But here it is not that complex because the weight TF-IDF is already embedded in TM package. So you just list this package here, but the whole line forms a function. Let's try this version of transforming. Maybe take a few seconds more. And later, maybe some of you may want to use the n-gram instead of the word. So it's finished. Let's look at the result. Now the number of words term is like more than 6,000. But here the frequency, maximum frequency value is not an integer, right? Has the point decimals now. And the fourth version is that you can try to use the n-gram, but it's not encouraged to do so because then the number of terms would surge. Like if we have like 10 words, then if you use 1 or 2 gram, then maybe you will get 100, at least 100 gram, right? Then, but some of you may want to try, so I just show you here. To use the n-gram, you need to load the rvector library because it has a function n-gram tokenizer, and then you can specify how many, what is the range of number of gram you want. Then, after defining this tokenizer function, you pass it to the parameter of the document term matrix, the tokenize. Then you can get the then the term will actually be the 1 or 2 gram actually, but the number would boost. I won't run this several lines because then it takes too much time. So we have created different version of the document term matrix, right? Next, I'll just use the third version and then start to chain and run the code, chain the model. The learner here is the naive Bayes. Maybe you want to use the tree, depends on your choice, or you may want to use some more sophisticated method. That's also fine. Then first we need to split the data to the training and the test set.
So you use a smaller one for testing, right? Remember, in the afternoon it runs quite long. So for testing, naive Bayes is quite long. I mean, for the test set, you just use 100 records, so we can see the results. It's fine. You run the training, it's fine. I mean, the test, you change it to 5, 4, 5, 9.
Yeah. but actually here, because in the afternoon the code may have some issue.
Okay.
Yeah.
So
now they are corrected.
Okay.
Yeah. So we split the whole data set to the training and test case. Actually, it's not the data set, it's the document term matrix. So this is a big matrix. Then the the previous around 4,000 documents are used as the training, and then the later nearly 1,000 are used as the test. Also, we need to prepare for the label. That is in the raw data frame is the type variable. So you may want to check the proportion of the ham for the training and the test. Okay. Since actually you can see now the matrix has like more than 6,000 column. What does it mean? How many variables we have then for the naive Bayes classifier? If we have 6,000 terms, that's just, if we have 6,000 terms, then we have 6,000 variables. That's a huge number of variables, right? Then you may want to remove some meaningless terms by remove some unnecessary and maybe some quite sparse term. So actually in this document term matrix, perhaps for example, if the first term is quite infrequent, then we maybe just want to remove this column. And a very good design of this package is that for this document term matrix, they have a very good raw name and the column name. So the raw name is just the text of each document, and the column name is each term. So we will make use of this good property of this package. How we do it? First, we remove some sparse terms here. You can see the remove sparse terms is also a function of the TM package. So you use the input is the matrix, and the second argument is the sparsity. That is, if the term's sparsity is larger than 0.99, then it's removed. So you can see if after we apply this, how many terms we have? Only 100 or more than 100. If we try to be more rigorous, then maybe less remain, only 50. So it means that in this, originally this matrix has 6,000 columns, now only remained with 50 columns. This is the sparsity actually may not be quite interpretable, and then you may want to further remove some infrequent word by just simply specify if the word frequency is less than 5, I want to remove it or something. So then you can just use this find frequency term function, and then it will returns here you specify the threshold. Then it returns a list of words that is frequent in this matrix. So here you run this code, and then you can get a set of words. Actually, it's still like 50. So maybe all the remained words we have filtered are all frequent enough to be remain here. So now we have like 50 words. And as I said just now, all the columns, they have a row name corresponds to the document, and the column name corresponds to those vectors. So if we want to refer to those frequent words columns, then we just use this SM frequent words, this variable. So that like suppose there are now it's 50 words. Suppose we have 6,000, then only the corresponding 50 rows will be extracted here, because the row name of this matrix has been well defined, right? So this is a very good property of those matrices. So we run the code here, and both the training and the test data set, they have been remained the same number of columns, the 50, right, correspond to the 50 terms. So we have been left with a more concise matrix. The final step we need to do is that the naive Bayes requires a categorical a predictor, right? We cannot use like such kind of a numerical continuous value. So we just apply the convert counts function to each element, so that if it has positive value, then you can convert it to yes. If it's 0, then it's no. It means that if the word has value like here, if here has value, positive value, then yes. If it's 0, then no. So everything becomes categorical, right? And then we apply this function to this to training and test data set. So the data are ready now. Then we start to train this naive Bayes model. First, we load the library to be used because it's in the E1071. Train the training set, and then apply the to the test set. Also, we can see the result. To run it again. I just skip this. The code actually is runnable. You can, maybe I have to do something other processing here. Okay, so you may also want to use other apply some parameters in this naive Bayes, like you may set the Laplace and want to improve the performance. So you are free to do so because you have been quite familiar with those packages, right? So this is the first version for text classification. It requires more data processing steps, but it's quite flexible, right? You can do whatever text processing step you want, and especially in the model training and the prediction step, you can specify the parameters quite as you like. And then we come to the text classification. It's quite simple, but later you'll find you'll be constrained by their frame. So let's first, as I said, the text classification. I will use the specialized package RTextTools. So this text cook has 9 algorithms. First, we just remove everything we've done. Okay, and then load the library. The TM package is always there because actually it will be used by the text tool. There's the dependency for those packages. Here I'll use another smaller data set, the counter review data set, which we saw just now. But here it just comes another column. So we are going to predict the rating, but it's quite a smaller data set. To save the time, it won't last too time for finish the code. So first we read the data set. And then the good thing about the RText tool is that you remember that we have gone through so many steps for data cleaning and the metrics, the documentary metrics creation, right? So everything can be done with this simple several lines of code. The create metrics. So this is inside the package. And but you need to be careful that the argument is not corpus anymore. It's just a raw text. So you can you can just use the data content to pass the argument here. And then also you do not need to do the steps, text cleaning steps one by one. You can just specify here whether you want to remove number or stem words. Actually, there are many other options you can do to do the text preprocessing. You can check the menu to see the full list of the processing steps you can do. So we create a matrix here. And then we can use the summary to see the number of documents is 34, and then there are more than 700 of terms. And then this is a summary of the frequency. So here I won't repeat every processing steps previously. I just directly go through this process. So after we get a matrix, the document term matrix, then we come to the second step. We create a container, and then the container will be used in every blocks in each of the following blocks. So what the container require is the document term matrix we just created, and what we are trying to predict is the sentiment or the rating actually here. So we do not need to split the data to training and test with additional codes of line. We just specify the chain size and the test size with these two parameters. And then it says that we're going to use the first to the 24th document as the training and the remainder as the test. The version, it means whether the test set is labeled or not. If it's false, then it means the test set is labeled. If the test set is labeled, then that's good, because then the algorithm will return you additional results with respect to the accuracy of the algorithm. If the test set is not labeled, then you cannot do the algorithm evaluation, right? So we create a container. It seems that the container contains everything we need to run a program, to run a machine learning model. So then we start to train the model. So we can use various kind of algorithm listed here. It also allows you to specify the chain model is inside the package. It also allows you to specify the some hyperparameters of the algorithms. Like here, you can check the menu to see all the parameters that you can specify. If you do not set these hyperparameters, then they just use the default value of the package. So we start to train these models. We can train use all the algorithms here. And then after training, we use the obtain the model to apply to the container. Actually, the container has already know what is the text set, right? So it will make the prediction on the test set, and then we'll just run this classifying model function. You will get the prediction for the test set. Here is a tips. That is actually the the neural network. For this neural network, the dependent package they use is the NNET. Actually, there are many R package for neural network, but what they are using is the NNET. So this for this here is removed because this package may encounter some issue for maybe some bug if you're trying to make prediction using the neural network algorithm with and trying to classify the binary label. So in this case, the package may come out with some error. So here is commented. So maybe you're trying to use this package, you may try to avoid this method, but you can try. And if after we train and predict those models, we can use a very simple create analytics function. It will do all the algorithm evaluation steps for us. And the very good metric for this function is that it will also return the ensembled performance of those methods. So because we have already used so many algorithms, right? So it combines all the results, and then let's look what's inside the analytics. it will summarize the performance of all the methods here, like SVM, precision, recall, etc. for each of the methods. And besides, here is the ensembled result. The ensemble result, you have learned the ensembled method, right? So the coverage means that how many percentage of the document would has for here this line, maybe for this line is better. For the n larger than 3, it means coverage is 1 means 100% of the document has at least 3 algorithms being agreement on the labels. If the n is getting larger, then it seems that it is very difficult for 8 of the algorithms to agree on the classification result, right? So the coverage is only 40%. Also, you can see the extract the value we use the at. Actually, sometimes you may use at, sometimes you may use the $sign. It depends on the data type or the class of this variable. But typically, you can refer to the manual. They will show you how you can extract the value. So you can see if you want to extract each element of this analytics. The analytics will contain 4 elements actually: the label summary, document summary, ensemble, and document. So the label summary is that it will show you the performance of those algorithms with respect to each category. We have this is the rating, right? So we have 5 categories. So for each category, it will show the performance. Like here, this is the topic summary. So for each topic, it will show the result for the whole performance. And this is the algorithm summary. It will show the result for each of the algorithm. But some of the result is NAM. That's because the result may for the ratings, not every ratings would have a record, right? And also for sometimes maybe the algorithm will predict that the label is 5-star for all the test set. Then maybe in this case, some of the result may be not available. So you can show us just use the at to extract the result. And finally, you can use the cross-validation if you want to check the performance of this method. The cross-validate is also embedded in the package, and then the container is passed here, and this is the algorithm you specify that you are trying to check the performance. Here is the 4-fold cross-validation. So you can run those lines and to see the performance. So okay, that's all the text classification part. If you have any question, you can just raise your hand in chat.
Container function can only be used for text analysis, or can be used for normal, other numeric data.
You mean this text package?
Because this container function, I think the first time we saw this, but looks like it's very powerful. Can be used for.
Oh no, this container function can only be used for text classification, because you can see the create container. They have a powerful name, sounds powerful name, but actually the works they can do is quite limited. So you can see the data type. They require a document term matrix. So not other types of the other data types. So you can only use the text to do the prediction. And actually, it's not that flexible because, as you can see here, when you use the naive Bayes method, actually you can construct your own training set by adding additional feature besides the textual information. But here, since the text classification, like here, it only requires the document term matrix. This matrix is different from the traditional, the basic R matrix. It's a specialized matrix that I said is a kind of in the sparse form and with some additional attributes, so that it can be recognized by the function. So you cannot just freely add some columns after the matrix. Like for each review, you may have the variable like the age of the reviewer or the time of the review, but you may not use this kind of matrix because it only require the document term matrix. But here, since the naive Bayes, like the SM chain, it can be data frame or matrix type, right? So you can just add the additional columns here to so that you can use additional features. Also, you can freely specify any of the parameters. And for the naive Bayes, there are so many packages, so you can use any package you like. But for the text classification, they have specified the package they use. Like for the SVM, they specify a package like the E1071, and like for the neural network, they specify the package NNET. And the NNET actually only require one layer of neural network. If you are trying to use like 2-layer or 3-layer, you have to use other neural network package so that you can freely set the number of hidden layers. So that's it seems the wrapper is kind of convenient because everything you need to call is the container. But you also have, when you have enjoyed this benefit, you also subject to some of the constraints of this package. So, okay, that's all the tutorial. If you have any, do you have any other questions? Maybe you want, if you want to do so, you can do so. But actually, maybe in the assignment, maybe it's not required to. Yes, but here the cross-validation, in this wrapper, it may not allow you so much flexibility in tuning the parameters. If you really want to tune the parameters, you have to use this method. So you can try to use like grid search or some combine with the carrot package we have used to do the parameter tuning. But in this package, actually, it is quite constrained to some extent. Yeah. In the assignment, you are not required to do so to reduce your workload, because actually the understanding all of those code and do the text processing is already takes much time. Do you have any other questions?